we have a computer and we're running Pro Engineer and we're frustrated, and it could go back to the point of sale. When you bought the machine, you may not have configured it properly, so we'll talk a little bit about that, some of the options at the point of sale, and then also some of the things that you can do to configure your workstation to maximize performance depending on what your job need is. So first of all, platform support docs at PTC. So I'm going to ptc.com here, and I'm going to go to the support page, and then Pro Engineer. I'm going to go into the Pro Engineer Wildfire 5. It's the latest version, so of course your mileage will vary. If you're running an older version, click into the previous version that you're using. See, there's some really good information here. I'm not going to go in and study all this stuff. I just want to give you a high-level overview and tour of how I use this and how I guide customers to answer specific questions that they might have about their hardware. For me, this page 3 is probably the better of the pages, because I can get in here and go right into specific HP hardware compliance, Dell's compliance, and any of the other vendors that I choose. So I'll dive into the HP model, and you can see here, this is Pro Engineer Wildfire 5 support for Hewlett-Packard products. So as we scroll down the list, we can see specific named machines. Which box is right for you? Well, it depends on what you're doing. If you need a whole bunch of cores and you're doing high-level analyses, then I would recommend something like this, because it's going to have more capability, more slots for CPUs, more memory capacity, and probably a higher graphics card capability. You can see the older legacy machines here. They're supported as well, even back to the XW series, going back a generation and a half. Laptops are also covered here. Something I want to talk about while we're here is certified versus supported. What the differences are between supported and certified is supported means they haven't taken the time to fully certify the machine. So if I'm looking at this list of choices here for the Z600, the FX 580, that hasn't been certified, but it's been tested enough to the point where PTC stands behind it, and they will support you if you call for support. If your box and machine and configuration doesn't show up on here, on any of these lists, that means it's unsupported, and PTC has the right to tell you they're not going to work with you to solve your problem. In those cases, you can always reach out to us. We'll help you as far as we can. Okay, we're going to jump back into the presentation. We just visited this site, and we learned that there are some new hardware available. So when we talk CPU, which one of these is right for me? And unfortunately, I've selected Intel for everything because AMD doesn't even show up on the radar any longer. So the i3 is the budget processor. I would not recommend this for anybody running any CAD platform, period. Doesn't mean that Pro Engineer won't run on it, and it is possible, but again, it's not supported, and it is kind of an enter at your own risk environment. The i3 is limited to a 32-bit architecture. It does have dual or quad core with hyper-threading enabled, but its intent is for basic computing. We would not recommend it for any customer. i5 would be considered the entry level. What separates the i5 and the i7 from the i3 is the 64-bit capability. Again, dual or quad core with virtualization. The whole point here is this is ideal for high performance gaming or graphics and video editing. We have to kind of align ourselves to the high performance gaming stuff. Again, that's why I started out with the PTC platform support page. That's a great place to get some guidance on where to go. The i7 is a high performance processor, 64-bit just like the i5, faster clock speed, higher capability, bigger cache. The cache is like the pipeline between the cores of the CPU and then the major systems within the computer. So the i7 is definitely the choice to go with. Now within the i7 there's different clock speeds, and you really can't compare an i7 clock speed to another processor. Stay within the chipset. Here's a comparison of my situation. 2 weeks ago I had my older laptop. It had an Intel processor in it, Centrino dual core. It was a T7300 class processor. The new Intel Core i7 is a slower clock speed, but look at the yields. I opened a massive assembly in product view, and as you can see, it was nearly 40 seconds on my old one and about 8 seconds on my new one. And my old laptop isn't even 3 years old yet. We're going to go out to a site put together by a gentleman in the Netherlands. His name is Olaf Korten. I always throw him kudos here whenever we go to his site. It's a great site. I've used it independently prior to working at EAC. Is a great place to go. So it's benchmarked results, and you can do both 64-bit and normal. So what we're looking at here is just a raw listing of the ranking. So first place is going to a non-supported box called Grumman Creations. So here you can see if you're going to win, you have to go custom so you can overclock things. And you see the OC here, that means overclocked. So they're taking a nearly 3 gigahertz processor and cranking it up to 4. I try to stay away from the custom stuff. You can see the first entry of a real product here is from Sun Microsystems. The first i7 occurrence here, you can see again, custom, and then Dell, of course, right here with this T3500 at 11th place. Just type in the filter here, i7, and I'll show you the stark difference between an i5 and an i7. First place box is at 829 seconds in the score. So 829 seconds is the fastest i7. Let's go hit the show on the i5. So the first i5 comes in at 23rd place at 30% higher number. So pretty dramatic difference there between the i5 and the i7. I don't want you to skimp on processor. If you can afford it, please go with the i7. You go back to his benchmark page. You can basically download his benchmark, and you can see the download link right here. And then there's detailed instructions on how to apply his benchmark. Graphics choices. Nvidia or ATI, those are our two choices. Anything else is not going to be supported. I'll just tell you that straight up. And within Nvidia and ATI, I'm a big fan of Nvidia. They rely on the same family of graphics drivers. So when they list PTC as a supported platform, they actually have somebody at PTC from Nvidia sitting in PTC's four walls. ATI doesn't have that commitment to our world. And that's not to say that they're not a competitive solution. In fact, in a lot of cases, they're superior to Nvidia as far as raw performance goes. But when you're trying to support a large environment, it gets pretty tough to manage the various driver sets that are needed for the various chips. So you can go out and buy the highest end, ultra high end solutions. You're probably wasting your money if you go anywhere outside of the mid-range products. It's definitely suitable for all pro engineer needs. Now I will talk a little bit about the high-end solutions. There are cases where the high ends would be applicable. Heavy animation analyses where animations are the result, mold fill analysis, those types of things can benefit from higher end graphics. Virtual memory settings. Virtual memory is very important. I've got 8 gigs of memory. First thing you want to do is don't let Windows manage your virtual memory. You want to take ownership over that, or have your IT people make sure that your box is configured at 1.5 times your physical RAM. There's some formulas that vary in industry. You'll hear some people will describe it as 2 times physical memory, and that depends on the operating system. I'm running Windows 7, so this is all about Windows 7. If you're an XP, you might want to back off this formula and change it to 2.0 times physical memory. The second bullet here is to eliminate the range of values. I eliminated the range by pinning it down to a specific value. There's going to be no floundering or wavering while the OS tries to figure out how much memory block it has to work with. Hard disk options. Don't settle for what you get in the basic disk. Typically you'll see 5,400 RPM. 10,000 RPM is a great median. You don't have to spend all the money and go ultra scuzzy with 15,000K drives. So when does it make sense to consider optioning up your hard disks? If you're doing CAE, if you're doing that, why not go the extra mile here and get some disk striping in place so that you can really make this thing fly? Anything in the HPC arena, you'll definitely want to apply this philosophy for. So what do you do if you meet any of these use cases? Consider the RAID configurations. 0 is striping, excellent for fast performance, setting many disks as one disk. This is an example. And let's just say you bought a new Dell T7500 that has multiple drive bays for hard drives. 4 drives would look like this in a normal scenario. Instead of saving files to each of these disks separately, virtualize that group of disks into one volume. When we save that one file, it writes 4 unique blocks to 4 hard drives all at once. The result is you get a 4 times faster simultaneous write time. Hardware performance conclusion, benchmark in your environment, make changes if necessary, or consult with us. We'd be happy to guide you through this process and provide any recommendations. This is where, as a reseller, we underscore the V in the value, and we are a value-added reseller, so that's what we do. And don't live with subpar performance. That's something that a lot of customers will put it on PTC and call us up and say, wow, Pro Engineer's really slow. And then I'll ask them, well, how old is your workstation? We had one case where, I'm not going to name customers here, obviously, but because it was a great success story, they had a box that was over 6.5 years old, and they said it was 3 years old. And when I did some more digging, they forgot that it was 6 years old. So we basically turned them around. They were running on a P4, actually, Pentium 4 processor. And I benchmarked his data set in my laptop, and it was my old laptop, by the way, so the old Intel Dual Core, so this one would have been about 40 or 50% faster, and it still beat his Pentium 4 by dramatic amounts. I think it was around the 60% faster range, and then I guided him to a solution, and he bought it, and he's very happy.